Alright guys, we are getting into the next section, or next part of the section. We are still in section 6.2, but part 2, now we are focusing on trapezoids. Okay, so remember, a trapezoid is a quadrilateral. It has one pair of opposite sides that are parallel, not necessarily congruent, until we get into isosceles trapezoids, but they have one pair of opposite sides that are parallel. And these non-opposite sides over here are called the legs. Okay, this and this are both bases. Okay, right here we have base angles. Here, I don't want to mark those as congruent, but right here and right here is one pair of base angles, because they are touching the same base. And then over here we have the other set of base angles. Okay, those are just the basics of a trapezoid. More specifically, in an isosceles trapezoid, again we have the pair of opposite sides that are parallel. Again, these are called the bases. But the important thing is that these two legs are congruent, just like in an isosceles triangle. You have two of the sides that are congruent. In an isosceles trapezoid, you have the two legs that are congruent. A few things about isosceles trapezoids. It makes base angles congruent, so those two are congruent. And these two angles are congruent. Okay, so we have segment segment EH is congruent to segment FG, and then we have angle E is congruent to angle F, and angle H is congruent to angle G. Okay, these are specifically in isosceles trapezoids. Also, the diagonals here are congruent. So we have that segment EG is going to be congruent to segment FH. Okay, these are specific to isosceles trapezoids. Now, something that I should probably mention that is with all trapezoids is that consecutive non-base angles add up to 180. So, for instance, the measure of angle F plus the measure of angle G is equal to 180 degrees. And then the measure of angle E plus the measure of angle plus the measure of angle H is equal to 180 degrees. Okay, this is in all trapezoids, even up here. These consecutive angles that are not touching the same base add up to 180, so they are supplementary. All right, so a few examples for us. We want to find the measure of angle P first. Okay, so the nice thing here is that we know that if angle R is 135 degrees, this other base angle right here is also 135 degrees, which we can actually just go ahead and fill in. And then we know that consecutive angles, non-base angles, add up to 180. So 180 minus your 135 gives you 45 degrees. So the measure of angle P is going to be 45 degrees. And then we know that these two base angles are congruent, so the measure of angle S is also 45 degrees. All right. Remember, you can stop these videos, write things down, and push play. Watch as many times as you need to help you kind of process all of this. I know it's a little more difficult since we're not in person, but we're going to do the best that we can. All right. Next, our next example, we have our exterior angle right here is 47 degrees. Find the measure of angle TUR. So angle TUR is right here. Remember, that middle one is our vertex. Okay, so angle TUR. Now, again, this is an isosceles trapezoid. So these two angles right here are going to be congruent. And since this forms a line right here, we know that that is a linear pair So we can do 180 minus 47. And that gives us, let's see, 133 degrees. So since angle R is 133 degrees, that tells us that the measure of angle TUR is also 133 degrees. And then we could also go on to find this angle right here, which is 47. Okay, because we have our parallel lines cut by our transversal. These are alternate exterior angles, 47 degrees. That's from a few chapters ago, just a little bit of a reminder. In our next example, again, we've got an isosceles trapezoid. We know these consecutive angles add up to 180. So to find the measure of angle 2, 180 minus 138, we get 42 degrees. So these aren't too bad so far. All right, now we are looking at our diagonals here. We've got an isosceles trapezoid. And remember, on the previous page, we said that our diagonals here are congruent to each other. So if two things are congruent, remember congruent means to set equal. Okay, so we've got that this whole diagonal is a plus 13, and this whole diagonal is 2a minus 1. So we are going to set them equal to one another. Okay, so first we subtract our a on both sides. So we get 13 equals a minus 1. Add that 1 to both sides, and we get 14 equals a. And we can always plug it back in to make sure. So 14 plus 13 is going to give us 27. 2 times 14 is 28, minus 1 gives us 27, and they are the same. All right, the last thing we are going to learn is the trapezoid mid-segment theorem. So your mid-segment, just like in a triangle, it connects the midpoints of the legs. Okay, so it connects the midpoints of the legs. So we know that x is our midpoint because these two pieces are congruent, and y is our midpoint because these two pieces are congruent. Now we have a trapezoid, so we have these parallel sides, and there's a few things that we can tell with the mid-segment. So first, segment BC we know is parallel to segment AD, but it is also going to be parallel to that mid-segment. Okay, all three of those are parallel. The next thing, and the thing that you'll probably use more often, is very similar to in a triangle where we knew that the mid-segment was half of the base. We know that this mid-segment, xy, is going to be half of your bases added together. Another way of looking at this is that 2 of those mid-segments is equal your bases added together. Okay, this is helpful when you have expressions. Okay, not just a simple 2, 3, 4, things like that. Okay, when you have expressions as your lengths, it's a lot easier. Okay, so for this first example, we see that these two are congruent, and these two are congruent. So this is not only an isosceles trapezoid, but it gives us our mid-segment. So we know in order to find the length of our mid-segment, we'll call that x. We know that if we take half of our bases added together, we can find our mid-segment. Okay, so 6 plus 9 gives us 15. So we have x is equal to 1/2 of 15. And half of 15 is going to be 7.5. So 7.5 inches is going to be the length of that mid-segment. we have 2 more examples. All right, so we want to find KL. Okay, we're working backwards a little bit here. First thing is we should probably figure out what this means. JM is 4/5 of 25. So let's find JM first. 4/5 of XY, so 4/5 of 25. Well, 1/5 of 25 is 5, so 4/5 is going to be 20. Okay, now, here is one of those times where it's easier to probably say that 2 of your mid-segment is equal to your bases added together. So 2 of our mid-segment is equal to our bases added together. Okay, so let's plug in those numbers. So we have 2 times 25 is going to equal KL plus our 20. Okay, we know that 2 times 25 is 50. We subtract that 20 on both sides, and we find that KL is 30. And, of course, we can check. Okay, so 20 plus 30 equals 50. And then half of that gives us 25. Which is exactly what our mid-segment was. All right, our last one, we're going to find BC, XY, and AD. All right, so again, this is an expression, so that's where it's going to be easier to take 2 of your mid-segment. So 2 of our mid-segments is equal to our bases added together. Okay, so we're going to distribute that in. 8s minus 4. Combine our like terms here is equal to 7s plus 1. Subtract that 7s on both sides. We get s minus 4 equals 1. Add your 4 over, you get s equals 5. So we're going to plug this in and check. So for BC, we get 6 times 5 plus 1, which gives us 31. For AD, that's just a nice 5. And then for XY, we have 4 times 5 minus 2. 4 times 5 gives us 20, minus 2 is 18. So we can check. Remember, these 2 are our bases. So if we add those 2 together and divide by 2, we get 36 divided by 2, which is, in fact, our 18. Okay, so you can always check to make sure that you did it correctly. Our bases over here added together, and then we divide that by 2 to get our mid-segment. All right, so again, you have an assignment that was given to you last week. Okay, make sure that you check Google Classroom for where to upload that. If you have any questions, just email Mr. Price or myself.